Hello everyone, good evening. Tonight I would like to give some tutorial to you, a recording video to explain more about the hypothesis testing. Okay, so first let's recall what we have learned so far. So first, we know that the general procedure for hypothesis testing, first one is we have to formulate two statements. What I would like to emphasize now is actually there are two statements. The first one is the initial claim to be proven, and the second one is the statement that will be true if the initial claim is false. So both of them should be in the problem. Okay, and then the second one, we need to set the null hypothesis. Null hypothesis only contains equality. And then the alternative hypothesis, or H1, which is only contain inequalities of the two statements above. And after that, we have to determine the confidence level or the significant level alpha. And after that, you have to determine the value of the test statistic from the sample data. And then we need to calculate the critical value variables from the table based on the alpha or the degree of freedom if you're using some tests like t-test. And also the properties of the hypothesis test. And then we have to also need to check if it is one-sided or two-sided calculation. And after that, we need to, after we calculate our position and also the critical value, we need to compare the statistical testing position, which from the position, the testing position versus the critical value, and then we have to determine is it in the area of rejection or in the area of non-rejection. And after that, we can draw a conclusion by referring to the initial claim to be proven. Okay, so for hypothesis formulation, based on the statement of H1, the hypothesis can be one-sided or two-sided. Okay, so let me have explain again about what does it mean with one-sided hypothesis. In one-sided hypothesis, the area of the rejection, it can be on the lower side, this one where the H1 is less than the initial claim, or it is on the upper region side, which is the one that we want to claim is in the area of rejection of the H null. Okay, so remember the H null, it always contains equality. So this is either, for example, for the mean, for the H null, the mu equal to the mu null, which is the mean of the population. So we claim that the mean of population is equal to the certain number that we claim. And then because of this is one-side hypothesis, the alternative claim can be that we claim that the mean of population is higher value than the initial claim. Or if it is one side in the lower side, it can be the mean of the population should be less than the mu null. Okay, in the two-sided hypothesis, the area of rejection, it should be have a significant level of alpha. So when you have the two-sided hypothesis, if the first one you claim that mu equal to mu null, the H null equal mu equal to mu null, which is the mean of population we claim equal to the one we claim, okay, with some significant level. Of course, with that significant level alpha, it should be ranged between this value to that value. Okay, and then where the area of rejection should be equal to alpha minus 2 and also alpha divided by 2, and also this one is alpha per 2. Okay, so the alternative hypothesis H1, that would be the mean is not equal to mu null. It's either less than or and more than. So this one, so because it is in the two tail, so we have to divide the significance, divide by 2, so alpha per 2 and alpha per 2. Okay, and then let's have a look again, the refresh again. So you have to remember about the difference between the testing. So we have around 5 cases, and then for number 5, there are A, B, C. So for the case 1, so this is the hypothetical testing for known sigma, or known the mean, the standard deviation of population, or is large samples. And the large sample is determined by the sample more than 30, where it can be assumed that the standard deviation of the sample, it can be similar with the standard deviation of the population. Okay, so in the case number 1 here, which is we know the standard deviation of population, we need to calculate the z-test for one sample. So this is the mean minus the mean of the population that we claim, and also divided by the standard deviation of the population, and per square root of n. Okay, and again, we have to check if it's going to be a two-tail test, upper tail test, or lower tail test based on the problem that we can see. So we're going to have a look later on, looking at some examples. The case number 2, similar with the z-test, but then we use a t-test, because if we have unknown standard deviation or small samples. So remember, if we have quite small samples, less than 30, but we have known standard deviation, we know the standard deviation of the population, we still can use the z-test. Okay, so I'm just going to go back here. If the sample is smaller than 30, but we know the standard deviation, we still also use the z-test. Okay, I'm going to go back to the case number 2. The statistical testing is the t-test, remember? So we have to calculate the standard deviation of the sample. And then also, this one is the mean of the sample. And this one is the mean of the population that we claim. Okay, and then we also need to calculate the degree of freedom, remember? So you have to open your table and then be familiarized with the table to check the degree of freedom, which is equal to n-1. Okay, so, and then for this one, so we examine that the t, it's also similar with the z. It can be two-tail tests in the critical region here, or on the upper and the lower for one-tail test. Okay, let me continue. Okay, and this one also I need to emphasize about the p-value. So what is p-value? Of course, you will see in the books that there are some formula about the p-value, but I think the better way to know p-value is using this graph. Okay, so this is the standard normal distribution. This is your z-critic, which is when you calculate the alpha, which is, for example, 0.05 and one-sided. This is the number. So the probability where the z-value when it's actually the probability when the tail is 0.05. This is the z-value. And let's say you are in the rejection area. Let's say your calculated z is actually 1.650. So you will say, okay, so I'm in the rejection area of the H null. So I would say there is no sufficient evidence to there is sufficient evidence to reject H null, because H null is in this area, right? Okay, but how significant is that? So how significant is that is actually because this is very close to the H null. This is the area of the acceptance of H null. This is the area of rejection of H null. We still unsure, is it close to here or not? So that's why we call this is a p-value. So this area over here, this is so the critical is 0.05 and the p-value is less than 0.05, but slightly less, which is 0.0495. Even though it is less than 0.05, this is still quite a large number. So in the literature or in many applications, we actually will reject the H null when the p-value is around 0.01. So maybe around here. So if we have the Z calculated, Z is maybe around here, which is the p-value is 0.01, we will really confident to reject H null. Okay, so in summary, the p-value is the probability when the H0 is rejected. So we compare it with significant level. So the probability that H null is rejected is around 0.0495. We usually confident to reject the value of the H null if the p-value is less than 0.01. Okay, so the p-value is a relative parameter to alpha, indicating how far the statistical testing goes into the rejection or non-rejection area. Okay, so let's go to the next page. Okay, so here, okay, so later on, if we compare it with the next one, let's say, if we can, let's say we calculate our Z value is in this area, which is, for example, we calculate our Z from the sample is 2.050, and then we can calculate the p-value. Usually the p-value we calculate it from Excel. We got the p-value is 0.0202. So it is less than this one. So we're actually more confident about this value that it should we reject the H null compared to this one. Okay, the case number 3, the hypothetical testing of variance for one samples. We use statistical testing, which is called the chi-square. Remember this one? So you have to use the chi distribution. So you have to know about the n, the number of samples. You also need to know your standard deviation, and also so the variance, standard deviation square, and also the standard deviation square or the variance of your population. Okay, and then you will get the chi-square, and the chi-square is always one-sided around this one. So it always this area. So if you have the significant level alpha, this should be your area or the probability, and this is going to be your chi-square. Okay, case number 4. Case number 4 is now we're talking about 2 samples, also again variance. So in the 2 sample testing of the variance, we're gonna use F test. So where in the F test, we compare two variants, which is the 2 variants, A and B, where the A should be the larger number compared to the denominator. Okay, so F test or F value always more than 1, and so in the hypothesis, if written in F, so usually the H null F null equal to 1, or the H1 F null more than 1.0. Okay, and similar with the t-test, for the table F, we have the degree of freedom and -1, and also is a function of significant level of alpha. So when you open your F table, you have to make sure that your significant level is in your right number. Okay, and then the last one, we just have some sub cases. There's 3 cases here. The choose samples testing of the means. So this is the for 2 independent samples. We know the a standard deviation of A and standard deviation of B, or we have both large samples numbers. Then we're gonna use the Z null test, the Z test, but for the 2 independent sample. And then this is the formula. Okay, and the second one, the 2 independent samples with unknown the standard deviation A and B, and also, but we have small number here. For the first case, if we know the standard deviation of population A and B, we use the T test, which is using the statistic test for the pairs, for the 2 samples. And also this is how to calculate the standard deviation. And then this one, if we don't have a similar standard deviation between A and B. So you have to determine which one is the standard deviation. Is it, do you dose the population, those 2 independent sample has similar or or not, okay? And then, so this one is the T one. Okay, so you have 2 sub cases. You have to check the equivalence of standard deviation test with the F test. All right, actually there is one more, the case number 6, which is paired samples. I'm sorry, I didn't put it here. Please check it again, the handout, but there are 2 sample testing of mean. There is the independent and also the pairs. So in the pairs, you will use the pair t-test, which is have a different formula with this one. So have a look about that one. Okay, so now let's have a look about the examples. So for example, so let's try to the pen, and then let's have a look about what we see here. For example, it is believed that a candy machine makes chocolate bars on average of 5 grams. So average 5 grams. So this would be the mu of the population. Okay, and then we call it a worker claim that the machine after maintenance is no longer make a bar. So so the claim, so we have 2 statement here. First, the candy machine makes chocolate bar on average is 5 grams. So this one, the number 1, this is statement number 1. Okay, and the second one, we have another statement. The worker claims that the machine after maintenance no longer make 5 bar. So this is statement number 2. So in statement number 1, we claim that the mu equal to 5 grams. And the statement number 2, it is claimed, the worker claimed that the average of the chocolate bar is no longer makes 5 grams of bars, or not a 5 grams for the average. So this one. Okay, so because the first claim, the first statement contain equality, so we can call this H null. And the second one contain inequality. It can be lower, or it can be higher than 5 grams. So it is called H null. Okay, so here you can see that the H null is the mu equal to 5 grams. So you put it there. And then the alternative hypothesis is this one, the second statement. So both statements should come up from the problem. Okay, so and then the possible outcome of the test, it can be reject null hypothesis or fail to reject hypothesis. Okay, in this case, because it is inequality, it should be there is a lower, it can be higher. So it's using one test or two tests, one tail or two tail. So yes, it's gonna use the two tail. Okay, so if you have a significant level of alpha, so the over here you have to find alpha per 2. This is also alpha of 2. This is the area is non-rejection of the H naught. This one is the area of rejection of H naught. Okay, so if your calculation, let's say, when you do the you do the statistic test, and if your calculation is around here or around here, okay, then you say that it's a fail to reject. Okay, but if your calculation, let's say, it goes into that way, okay, in this area, so you can say it's sorry, I think I missed with the eraser. So if I need to calculate there, let me check again. So if you're in this blue things, your calculation, your Z calculation from the samples in this area, then you said you're in the rejection. So you have to reject the null hypothesis H null. If you're in the green area around here, so you're actually in the non-rejection. So we didn't say we accept H null, but we say that we fail to reject H null hypothesis. Okay, so the statistician will never accept the null hypothesis. So we will say that we fail to reject. In other words, we'll say that it isn't, or that we don't have enough evidence to say that it isn't, but we'll never say that it is, because someone else may come along with another sample which shows that it isn't, and we don't want to be wrong. Okay, so hopefully from this example, you can understand about the basic that need to really check. So both of the claims should be in the problem. Okay, so and then based from this one, we accept, which we see that it should be the H null or the H1. Okay, and then later on, of course, from do the testing, you have to the test statistic. Let's say you take 50 bar of samples, and then you calculate the mean. You can calculate the standard deviation, and then from that one you check the Z test, and then you can draw where is your Z compared to the Z critical. Okay, right. Okay, so let's have a look at this one. Okay, so the company has stated that the straw machine makes a straw that is 4 millimeters diameter. A worker believes that the machine no longer makes straw of this size, and a sample of 100 straws to perform a hypothesis test with the 99% confidence, and then write H null and also the alternative hypothesis. Okay, so let's have a look about the first statement. So the first statement says that the straw machine makes straws that are 4 millimeter diameter. So this is the claim that the mean is a 4 millimeter diameter. Okay, so the first claim, we call that the mu, or in mathematically, we claim that equal to 5 millimeter. Or maybe let's say equal to mu now. Okay, and then the worker believes that the machine no longer makes straw. So we have another claim over here that actually we call it alternative claim, or the claim number 2 over here, that the worker believes that the machine no longer makes straw this size. So we didn't claim that one. Okay, so again, you have to check where is the equality and where the inequality. So of course you can guess that the equality would be in the first claim, the number here. So then the H null would be maybe it would be mu equal to mu null. Okay, and then after that, the mu this is the inequality. So this one, which is contained inequality, you can claim this one as an alternative hypothesis, which is mu is not equal to mu null. And again, because it is not equal, it can be lower than or higher than, you can claim that it is one tail to tail. You can claim this is a two-tail hypothesis. Okay, and then this is 99% confidence. So the alpha would be 1 minus 99%, or about 1%, or about 0.01. So the confidence level around this area, the significance level, actually alpha over 2 should be 0.005. So you have to find the z, which can get 0.005. This is your Z critical. Okay, this is your Z critical. And after that, this practice is not complete, so you have your n strolls. Yeah, this is the n, so you have the n 100. So maybe from this one you can get your the mean of the diameter from 100. So you get the mean, and then you can calculate your Z, and then check your Z, is it in the area of rejection or in the area if known rejection. Okay. All right. So hopefully this quite similar with the previous one. Okay, so this one again. Okay, so the doctors believe that the average teen sleeps on average no longer than 9 hours per day. Research believes that teens on average sleep longer. So write age null and age 1. I think the assignments here are quite pretty consistent, where the first claim or the first statement is H1 null, and only the second statement is H1. But sometimes it can be changed. So let's have a look about this one. The first one, doctors believe that average teen sleep average no longer than 9 hours a day. So I will say that number one, the average sleep is no longer than 9 hours. So no longer than, tidak lebih besar dari. So I think it should be, in calculation we can call it, in the mathematical we can call it no longer than 9 hours. So the higher it should be 9 hours, but no longer than 9 hours. So no more than 9 hours. So maybe I will write it at equal to mu null. Okay. So this is the mu null, yeah. So for the 9 hours. Okay, and then the research believes that the teen's average sleep longer, which is longer than 9 hours. So the second claim, it is the average sleep is longer than the number. Okay, so what we see over here, that we have to check about the equality and the inequality. Okay, we see here also it's written that the equality is in this one. Okay, so then the H null, we can claim that the mu equal to mu null. Okay, and then the H1 would be the other claim, which is mu larger than mu null. Okay, so this is our convention. I have talked to Pak Miki about this one. Even though the claim is actually written as less than equal, but for the H null, for our convention, just use always equal in the H null. Okay. All right. So hopefully from those three examples, you can get some more ideas and then maybe more understanding. Maybe you can repeat again also. Now let's have a look about this one with our understanding to go to the next example. Okay, so this is example 4.10, which is about bottle filling. An automatic filling machine used to fill bottles with liquid detergent, and a random sample of 20 bottles result in sample variance to fill volume of variance 0.0153 fluid ounces square. Okay, so just maybe written some notes. This is bottles, which is n equal to 20. I would say also it's about the variance and also a sample variance. So you can claim that it should be one sample of variance. So this could be hypothesis testing. Hypothesis testing. Okay, and then we have to really take care, check about the statement here. If the variance to fill volume exceed more than 0.01 fluid ounces square, an acceptable proportion bottle will be underfilled and overfilled. Okay, so here we say we have the first claim. If the variance of the fill volume exceed, so this one. Okay, so the number one here that we can see that, yeah, this one, exceed. So the first statement, the variance exceed 0.01 should be more than. Okay, so it is unacceptable to be underfilled and overfilled. Okay, so that's not good. Okay, so is there any evidence? So this one we can write as S square exceed, so more than 0.01. Okay, and then we have to check the claim, another claim from here. So is there evidence that the sample data to suggest the manufacturer had a problem with under and overfilled bottles? So there's no really exact claim over here, but then the alternative hypothesis, it is more than. So the other one should be S square. Should be more than, so it should be less than equal. So the complementary of this one. Okay. Now, what we need to really ensure from these two claims, which one is have the equality? Yeah, the statement that have equality is the statement number 2. That one. So for the statement number 2, then we have to put this as the null hypothesis. And in the null hypothesis, we always, so the convention like we talked before, this is not S squared, it should be, sorry, it should be the standard deviation of the population, not the sample, sorry for that. So this would be the the sigma square 0.01. Okay, so the equality. So from here we can get we can write that the variance of the population equal to 0.01, the hypothesis. Okay, the alternative hypothesis, we're gonna use the statement number 1. So this, because this is inequality, and then we use the statement number 1, which is become this one. Okay, so I think this is improve our understanding, my understanding too, actually, about, actually, it's not always that the H0 is taken from the first statement. It can be taken from the second statement if the second statement contains equalities. Okay, so after that so now after the alternative hypothesis, so this is going to be the H0, which is the always contain equality, and the alternative H0 is actually came from the first claim or from first statement. It came from the if the variance of fill bottle exceed that one, because it's more than melebihi, yeah. So in the test statistic, because it is one sample of variance for the hypothesis testing, we can use the chi-square. So it is actually from the n is 20, so it should be 19, multiply with the standard deviation of the sample, which is 0.0153, divided by the standard deviation of the population, which is that we claim 0.01. Okay, and then to calculate this one, so this would be the 29.07. And don't forget to check the this one is the chi-square critical which is we got it from the chi-square when the significance levels of alpha 0.05 from here. And the degree of freedom is 20 minus 1, which is 19. Okay, which is that one. Okay, so in conclusion, because the chi-square is less than the critical, so it's gonna be looks like that. If this is the critical, maybe you let me, okay. So let's say if this is the chi-square critical, which is, or sorry, for example, this chi-square critical, which is 30.14, our value is in this area, which is 29.07. It's slightly similar, only 1 point. Okay, so and then we have to say that go back to there. So this is the area of rejection. This is the area of fail to reject. Okay, because now the blue one is in the area of fail to reject, so there is no strong conclusion of the evidence that the variance will exceed this one. Okay, now so now the question is how to is it strong enough? Yeah, there is no strong evidence to reject. So we see that the p-value is in this area. The probability from the H0 to reject. Oops, I need to. Okay, so there's no strong conclusion to reject. So we see that the p-value would be, if calculated, is 0.05, 0.065. So it's going to be a weak conclusion. And then we need another experiment with a larger sample that should be considered. I'm going to stop it here, and I'm going to put it into another, maybe another video.